Hey guys, we are looking at the basic concepts of time and distance today. This is an important topic for all competitive examinations. Supposing you are riding a bike at 50 kilometer per hour, and if you keep riding it for 4 hours, how much would be the distance you cover? The distance you cover will be 200 kilometer. If distance is denoted by d, speed denoted by s, time denoted by t, this is what you get. This is the only basic result to be learned in time and distance. As you can see, there are three variables in this simple result: distance, speed, time. Supposing you allow two of the variables to vary, keeping one of them constant, there are a few things you can derive from that. For example, supposing d is kept constant, what do you get? S into t will be some constant. This implies what? These two variables vary in such a way that their product always remains a constant, which means S is inversely proportional to T, which implies what? The more of S, the less of the other variable. Say, look at this. If you're riding your bike from your home to college at a certain speed and at a certain time to reach the on time, and one day, supposing you are reducing the speed, obviously the time taken will be a little longer. Here, the distance is a constant factor because the distance from your home to college does not change. The only thing is that if you're riding your bike faster, the less the time you take to reach the college. That's a simple example to illustrate this point. Or rather, we can say if you take two sets of values, as you've seen in inverse proportionality, S1 T1 will be equal to S2 T2. Take this formula again. This implies you can write it like this. Let's keep time constant. Then what do you have? If time is kept constant, d by s will be a constant. What does that show? Here you have two variables, distance and speed, varying in such a way that its ratio always remains a constant. This implies d is directly proportional to s. That implies d1 by s1 equal to d2 by s2. See, I'll show you an example. If there are two people, say, running for the same length of time or duration of time, what do you see? The one moving faster will cover more distance. That is the implication of one variable being directly proportional to another variable. The more of one, the more of the other also. And this is an example to illustrate that point. These seemingly simple results are very useful in solving even some of the complicated problems in time and distance. So keep in mind this basic result, speed and time being inversely proportional and distance and speed being directly proportional. These few points will help us a lot in tackling many problems. I will go through a few simple problems to illustrate these basic points. Look at the first problem. One day while leaving from home to office, I travel at a speed less than my usual speed and take 33 and 1 by 3% more than my usual time. How much is the reduction in speed percentage wise? See, neither of the variables like speed and time are given in the problem, and distance, as you know, from home to office is a constant. It doesn't change, but that also not given in the problem. Finally, we are asked to find out the reduction in one variable percentage wise. So normally in such problems, what do? Take whatever is not given as some convenient numbers for ease of calculation and proceed. So this is the formula to be used. D is equal to speed into time. What you can do is let S be 1 unit and the time taken is also 1 unit. On the basis of these two assumptions, distance will be 1 unit. Speed has been reduced. Accordingly, he has taken longer to reach the office. How much longer? 33 and 1 by 3% more. Rather, time 1 is getting increased by 33 and 1 by 3%. 33 and 1 by 3% means divided by 100. This on simplification, you will get 1 by 3. So to increase time by 33 and 1 by 3%, you will increase it by 1/3. When you increase this by 1/3, what do you have? Initially 1/3, and that will come to 4 by 3. So this will be 4 by 3. Now, there's a reduction in speed. We don't know what it is. Take it as a variable. And what about the distance? Distance always remains the same because the distance from home to office doesn't change. So that will be 1 again. And this implies what? Keeping S here, you take 4 by 3 to the left side. So you will have 3 by 4 equal to S. That means S is equal to 3 by 4. So what do you observe? There is a reduction in speed from 1 to 3 by 4. 1 getting reduced to 3 by 4 means it's getting reduced by 1/4. 1/4 means 25%. So speed is reduced by 25%. That's the final answer to the question. The second problem is this. While traveling at 30 km per hour, I'm late for office by 20 minutes. So to be on time, I increased the speed to 50 km per hour, but still I got late by 8 minutes. What should be the correct speed to help me reach office in time? We don't know the distance between home and office. Let it be D. First, it travels at what speed? 30 km per hour. So to cover this distance, this will be the time he takes. As you have seen, D by S is time. He is getting late how many minutes? 20 minutes at this speed. He increased the speed to 50 from 30 km. Second time he will be taking so much time. This is distance, this is speed. So distance by speed, as you know, is time. There are two durations of time here. At this speed, this is the time, and the time taken is, we don't know how much time it took, but he got late by 20 minutes. If we go at this speed, he is getting late by 8 minutes. Can you see something? When you move faster, there is a gain in time, and the gain in time will be this minus this. That means when you increase the speed from 30 to 50, the gain in time, or rather he is taking 12 minutes less. That is the indication of data given in the problem. Now, this is 30 km per hour, this is 50 km per hour. So 20 minutes won't make sense here. You convert that into hours because you got to make the units uniform. One is in hour, the other is in minutes. And this will be, so 1 by 5th of an hour is what it gains by increasing the speed from 30 to 50. Let me write that equation again. D by 30 by D by 50 equal to 1 by 5. So you got a simple equation with one unknown, D. You can easily solve that. D is common. 1 by 30 minus 1 by 50 equal to 1 by 5. This implies, this on simplification, 30 into 50, 50 minus 30, 1 by 5. This on simplification, you can cut it like this. 25. So you have 3 into 25, 75, that will go out. So 15 kilometers. So we have solved the distance between the office and home, which is 15 kilometers. 15 kilometers. Initially he covers at what speed? 30 kilometers per hour. So what will be this? This is the time he takes while traveling at 30 km per hour. This is distance, this is speed, and that gives you the time. We know that the correct speed should be more than this. Let S be the correct time to reach office on time. So 15 is the distance to be covered. That divided by S, he will be reaching the office in time. And traveling at 30 km per hour, he is getting late by 20 minutes. Rather, when you increase the speed from 30 to S, we don't know what it is, but when you increase that 20 minutes gain will be there in time duration. Rather, this is equal to 20 minutes. Like I did, here everything else is in hours. So you convert this into hours. That will be 1 by 3. I hope you understand this. So when you increase the speed from 30 to S, whatever time you had taken more, will be getting reduced to 0. That's the meaning. So you have this equation. What you can do is 15 by 30 is 1 by 2, and 1 by 3 you take to the left side. Okay? 15 by S to the right side. You have this one. And this implies This on simplification is 1 by 6. And that implies cross multiply, you will get S is equal to 6 into 15, which is 90 kilometer. Sorry, it's not kilometer per hour. So he has to travel at 90 kilometer per hour to reach the office in time. See, look at this, 90 is more than both 30 and 50, which it should be, because even at 50 kilometer, he is unable to reach the office on time. So anyway, that number is should be more than 50, and we got it as 90. There's the final answer to the question. We have worked out two simple problems to help you get a better idea on the basic concepts I have gone through in the time and distance. If there is any doubt still you have about these two problems and the concepts I covered, feel free to raise it in the comment section. I will address it there. See you guys in my next video, where I will help you with smart solutions to problems that are even trickier than whatever I've done here. Bye for now.